This session, okay.
Good evening, sir.
So I will share my screen. Please let me know whether it is visible.
Yes, yes. Yes, sir, sure.
Yes, I am sharing.
Yes, sir. Visible.
Is it visible?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Yes. Yes, sir.
Okay, so can we start because it is already delayed.
Sure, sir.
Okay. Okay, once again, good evening to all. And today is the last session of our training program.
Good evening, sir.
So yesterday we saw which tools we saw. Can anyone tell me which tools we saw or which tools we learned?
Check sheet,
Scatter diagram, Pareto chart,
scatter diagram, and Pareto chart.
cause and effect diagram.
Pareto chart, scatter diagram, and we just started the fishbone diagram, right? So, fishbone diagram has three names. I told already that it is called as Ishikawa diagram because it is invented by the Karo Ishikawa. It is also called as fishbone diagram because it's look like a skeleton of a fish, and it is called as cause and effect diagram, right? So, because I will use pointer. So this is called as cause and effect diagram because these are the causes and this is the effect. Okay. So this is also called as cause and effect diagram. So it is clear till here. So three names: cause and effect, fishbone, or Ishikawa. Okay. Now we need to draw this diagram. So how to draw it? Okay. We will learn step by step. So first step is to identify and define the effect. Here effect means problem. For example, crack or poor mileage of my bike. Particularly, I'm taking a generic example. So, identify and define the effect on which you are going to work. For example, here I selected poor mileage of a bike. So, firstly, we need to identify. Okay, that is step number one. It is clear. I have selected a problem. It may be a crack, damage, shrinkage, poor mileage, any. Clear? Step number one.
Identify and
Yes, sir.
Identify and define the effect. So here I identified that poor mileage of a bike. I am going to resolve this issue. So select the issue which you are going to resolve. So you may select crack, poor mileage, shrinkage, whatever your defects. Here I have taken poor mileage of a bike. Okay. This is step number
It
one.
may be effect or defect, sir. Both we can have effect or defect.
Hello. Step number two. Now fill the effect box and draw the spine. This is called as spine and this is called as the box, effect box. So in step number two, I need to draw a box here and I need to write the name of the problem. The problem is poor mileage of a bike and I have drawn the spine. So this is step number two. Clear? Step number one, step number two is clear?
yes, sir.
Yes or no? Okay.
Yes,
So
sir.
these are very simple steps. In step first, we selected the problem. In step two, we draw a box. We write down the problem in that box and we draw the spine of the fish. Okay. Or we draw. Okay. Now we will go to the step number three. Step number three is to make a skeleton. So I have make a skeleton of fish, man, oblique woman, machine, method, and material. Normally we are using 6M. But these 4Ms are contributing a lot. So I have selected here 4M. So you can select 6M as well. But most of the 4Ms are contributing. So I have selected 4M.
Sir, I have a query.
Yes, please.
Sir, why these four factors are affecting the mileage of a bike, sir? Environment as well as mother land also affecting. As if the resistance of the air will be more, the
Yes, yes.
bike's mileage will
Yes,
be less.
I am just giving an
This is
example.
basic example.
Yes, you can write it because first step is we need to understand the concept, right? So how to draw the
Yes, yes.
fishbone diagram? So it is to be drawn in 5 steps. Step number one, select a problem. Step number two, draw a box and draw a spine. And step number three is make a skeleton. You can use 6M as well. And here
This
we
is
can
for
put
our
a
understanding.
problem of a crack. So water bottle is cracked, though you can put a problem, correct? Okay. Now, after drawing this skeleton, we need to stop here and we need to start the brainstorming. So what is brainstorming?
Generating the ideas
Generating the ideas. How you generate ideas?
by collecting the
With,
data
with team, sir.
from till
Okay,
the
suppose there are 10 people in my project team and I am the coordinator or the facilitator. Suppose after 7 kisses you will be facilitator. So there is a 10 members in your team. So what you will do? So you will give a post-it to each and every member. So post-it is clear, na? Post-it, that sticky notes. So, and please tell them to write what they think on that post-it. One idea on one post-it. So he may write 12 ideas, 10 suggestions, but he will use 10 post-it. If 5 ideas, he will use 10 post-its. So what is brainstorming? It is a concept of collecting suggestions and ideas from the members present in the meeting. And we normally use this method for solving the problems. And this brainstorming method is developed by Alex Osborne in 1953. So normally, what are the guidelines for conducting brainstorming? No criticism or questions. So do not ask any question. Please be in silent mode. So just give post-it to all of the participants. Suppose there are 10 participants, give them a bunch of post-it and tell them to write down one idea on one separate post-it. So if you have 10 ideas, he will use 10 post-it. No idea is a bad idea. Do not resist. Whatever he or she writes, please allow them. Okay. And if he is writing out of box ideas, that is always welcome. So do not restrict. Then as soon as idea comes in your mind, write down. So most of the times they are thinking. So as soon as they came the idea, please write down. So that is the instruction. And we need to avoid the hippo effect. Hippo means highest paid person's opinion. Normally, I observe that when there is a plant head or GM or VP, they are actually emphasizing their opinions. So we need to avoid this hippo effect. And hence, normally I conduct brainstorming or I can call it as a brain writing, means not speaking a single word. Silent brainstorming means give them 10 minutes, 15 minutes. Do not speak a single word. Just they will write down whatever comes in their mind and then collect those post-its. Okay. So I am again repeating. So we have very few time today. So I am again repeating. Step number 1 is identify the problem. Here I have selected a poor mileage of a bike. Just understand the concept. Second step is the fill the effect box and draw the spine. I draw it. Very good. Third is draw the skeleton and wait. So after drawing a skeleton, please distribute the post-it and start the brainstorming. And after brainstorming, write down. So ask the question now. For example, what are the causes related to man which will cause poor mileage of a bike? I'm just taking a generic example. Take your defect, for example. What is the crack? So what are the reasons for a crack related to man? So he may be not trained, he is not skilled, he is not motivated. So he is not trained like that. So related to material. So material is not as per the specification like that. So whatever ideas, please write. So here I did. So poor mileage of a bike. So normally, these are the some examples. When you do brainstorming, lots of ideas will come. So here there are very few ideas I collected. So related to machine, here my machine is bike. So low air pressure in tires is one of the cause which cause the poor mileage of a bike. So step number 4 we are studying. The step number 4 means primary causes that influencing the effect. Which are the causes, primary causes which influence the effect. So low air pressure in tires, it may affect the poor mileage of a bike. This is I written in machine. Method, use of wrong gears. Normally he is using wrong gears. So always running the bike on first gear, for example. So this is not a good method. So it is a use of wrong gears which may lead to the poor mileage of a bike. Driving too fast. Normally speed should be near about 50 in cities and 70 near to highways. But if he is running very fast, that can be a reason or cause. which will affect the poor mileage. Okay. Related to material. Inferior quality of petrol. Inferior quality of petrol may lead to the poor mileage of a bike. Improper lubrication, it may lead to a poor mileage of a bike. And in man, bike not maintained by the driver. He is not aware how to maintain the bike. He is not doing servicing regularly, and his driving habits are not good. Please be in silent. Please be on mute. Okay. So this is step number 4. Step number 1 was selecting a problem. I selected a poor mileage of a bike. Step number 2 was draw a box, poor mileage of a bike, and draw the spine. I draw it. This was the step number 2. Step number 3, draw the skeleton. You can draw 6M, but here I draw the 4M just for your understanding. Then start brainstorming, and after brainstorming, write down the causes. So these are called as primary causes. Okay, this is step number 4. Only one step is remaining, then our fishbone diagram is completed. So constructing a fishbone diagram is completed in 5 steps. But after that, we need to do, I will tell you in upcoming slides what we need to do. Okay. Now only one step is remaining. That step is called as identify secondary causes. So secondary causes means, for example, low air pressure in tires. This is a primary cause. And why low air pressure in tires? Here I need to ask a question, because not checked, no frequency decided to check the air pressure in tires. So that is the secondary cause. Okay. Now I will tell you the difference between secondary and primary. Primary causes means if they are present, they will directly affect to the poor mileage. What is secondary causes? Suppose I have not checked the air pressure, it will directly not hamper the poor mileage. It will result into the low air pressure or high air pressure, and it will lead to the poor mileage. Okay. So that is called as the secondary causes. For example, my driving habits are poor. So poor driving habits, and why poor driving habits? There is no training or skill. So I am not trained. I don't have the skill to run the bike. So this is a secondary cause. This will lead to this, and this will lead to this, like that. So this is called as secondary causes. So once again, I will repeat. When you are going to construct a cause and effect diagram, there are 5 steps. First, select a problem. Then select a draw a box and draw the skeleton. Third, draw the 4M skeleton or 6M skeleton. Then do a brainstorming and write down the primary causes. So primary causes means if that primary cause is present, it will directly affect to the poor mileage or a problem, right? Then draw the secondary causes. So now in 5 steps, we have completed the cause and effect diagram. Okay. So what next now? We have completed that. These are the causes or sub causes or primary causes and secondary causes for a poor mileage of a bike. Then what we need to do?
Evaluation of the causes, sir.
Okay, verification of the causes, but how to do that?
Gemba. We have to visit the Gemba, and then
Okay.
we have to identify them whether it is happening or not, without giving the information to anyone.
Okay. So that is the correct point. Normally, draw the fishbone, involve the brains, write lots of ideas. Sometimes I wrote 62, 72 ideas or more than that. So it will be a big fishbone. Then we need to verify the causes. We need to verify the causes. Suppose there are 30 causes or 60 causes. Out of that 60, which causes are affecting the poor mileage? So this is a brainstorming. Whatever came in my mind, I wrote down there. So that is the correct approach. That is called as cause verification. Now these are called as possible causes. These all are called as possible or potential causes. But we need to go to the possible to the significant causes. And normally we do the Viva analysis on significant causes. We normally don't do the Viva analysis on possible or potential causes. So we do the Viva analysis on significant causes. But how to identify whether that cause is significant or not? So there is a one method that called is cause verification. How to do that? So there is a one chart. Suppose this is a cause verification chart or cause verification process. Write down all the possible causes which you identified. So for example, I wrote down the 3 causes which I identified. So you can write down all 28. So write down all the 28 causes one by one, one by one. So this is the first step. Write down all the possible causes. Make an Excel sheet. Write down all the possible causes. This is column number 1, serial number, column number 2, possible causes. Very good. Now write down the specification in column number 3. What is specification? Low air pressure in tire. For what as per manual? For example, my bike is Jupiter. So I have a Jupiter. So 24 psi in the front tire and 32 psi in the rear tire. This is as per the manual specification. Okay. So this is the specification given by the company. Okay. Now I need to check. So Gemba means I need to check on the bike. And suppose I observe that 20 psi in front and 28 psi in rear tire. Oh, specification was 24 psi and 32 psi, but my pressure is 20 psi in front and 28 psi in rear. Then I am saying that this is not okay condition. So I am putting it as a red. And I remark will be it may be a significant cause. We need to collect more data. So we need to check once or twice, two times, 3 times, going to the game bar, collecting more and more data. Okay. Now, second cause I wrote down was bike not maintained by the driver. Okay. That was the one of the cause discussed during the brainstorming. Okay. What is specification? Regular maintenance and servicing of a bike from a good workshop or your company workshop. Okay. Now I need to check the data by going to the game bar. And I observe that bike found maintained in good condition, regular servicing is there, regular maintenance is there, bike is starting in first kick, very well maintained. So I found this as okay. So our remark will be non-significant. Do not require any action on that. Remove that cause. So I can scratch that cause. So I am not going to study further. Okay. Then driving at high speed. Okay. What is the specification for a good mileage? 50 kilometer per hour in city, 70 kilometer per hour on highways. Data source Gemba. When I check that speed, the driver is driving at 100 kilometer per hour on highways. Oh, then it is against the specification. It is not okay. So it is a significant cause. Clear? How to do a cause verification process? Write down all the causes. Write down the specification. Check at the game bar. 3G concept. Always remember 3G concept. Genchi Gembitsu. Go to the game bar and check the data. Observe the condition, real fact, and put it either okay or not okay. If it is not okay, then you can treat it as significant. So we need to collect more data. So accordingly, you can do all the cause verification process. And suppose out of 28 or 20, I came to know that there are 5 to 6 are the significant causes. Then I need to do a YY analysis on the significant causes. I will identify the root cause and then I will take action on it. So this sequence is clear. First, we learn how to draw a fishbone in 5 steps. Select a problem. Then draw the problem in box, draw the spine, then draw the skeleton, do the brainstorming, write down the primary causes, write down the secondary causes, then do the cause verification process, and which are the significant causes, do the YY analysis. Okay. So we are not going to cover the YY analysis here, but this is just an example. You can take a photograph. So observation, leakage of oil on shop floor. So why there is oil leakage? Machine is leaking the oil. Why? Gasket is broken. Why? We purchase the gaskets of inferior quality. Why? Focus on cost saving instead of quality. Why? Purchase performance is evaluated on short-term cost savings. So this is the reason, because purchase performance is evaluated on short-term cost saving and hence purchase is purchasing the gaskets of inferior quality. And action is purchase performance should not be evaluated on short-term cost savings, quality to be focused. So this is just an example of YY analysis. And there is one trick. After completing YY, you need to use therefore technique. What is that therefore technique? Suppose last Y is purchase performance is evaluated on short-term cost saving. Now ask therefore from here. So purchase performance is evaluated on short-term cost saving. Therefore, purchase is focusing on cost saving instead of quality. Therefore, purchase is purchasing the gaskets of inferior quality. Therefore, gaskets are breaking and therefore machine is leaking the oil. If your YY analysis is correct now, then that when you use therefore now, there will be some logical thinking. Your flow will match. And if Viva analysis is not clear, now you will not get the correct answer. So here, just check the flow, just check the relevance. So purchase performance is evaluated on short-term cost saving, correct? Therefore, they are focusing on cost saving instead of quality, correct? Therefore, they are purchasing the gaskets of inferior quality, okay? And therefore, gaskets are breaking like that. So this technique is called as therefore technique. So after completing YY, please check with therefore. And if your YY is correct, there will be some logical flow. You will understand that yes, my YY is correct because my answers are coming right. If it is not clear, then my answers will not correct. Correct. It will. I can say when doing the therefore technique, you will find that no, there is no logical sequence or there is not my causes are not matching like that. Okay. So this is the fishbone diagram. Okay, but this is a very simple Viva analysis. This is a multiple leg Viva analysis, which I think we can skip because most of the time significant causes, when you ask the first why, there will be lots of subcauses, not single subcause. Here only one. For example, here may be three. So again, you need to go to Gemba check. So this is not the cause. This is not the cause. This may be the cause because yes, I checked on Gemba. Okay. Now again ask why here. So again there will be two subcauses. Oh, I will check again on Gemba. This is not subcause. This is found correct. So this is the subcause, sub-subcause. Okay. Now again ask why here. Then there will be two subcauses. Then I check on. Hello, please be on mute. Please be on mute. So then this is the root cause. So this is called as multiple leg Viva analysis, where there are with multiple answers and you need to validate each and every sub cause on Gemba. And then you need to check, yes, this is not a sub cause because if it is okay, okay condition as per specification, it is okay condition. Heat is not as per specification, not okay condition. Again, there will be two sub causes. This is okay. So I will focus on this cause. Again, I will ask the why. So there will be again two reasons. This is okay. I will again ask why here and I will get the root cause. So this is how we complete the fishbone. So it is clear. So fishbone.
Yes, sir.
Yes. So now we will move to the second tool that is called as histogram. But before discussing on histogram, let's discuss some of the basic statistical concepts. We on day one we learned mean, median, and mode. Okay. Now we will learn what is range. Range means difference between maximum value and minimum value. If the values in the data sets are 9, 8, 8, 4, 5, 5, 5, then the range is 9 minus 4 is equal to 5. So range is simple difference between maximum value and minimum value. Suppose we are 100 people and one is having highest weight of 120 and one is having the lowest weight of 60, then the range is 60. 120 minus 60. So that is range. Difference between maximum value and minimum value. Okay. Then this is the concept in Six Sigma, but just I will go through it. Standard deviation. What does it mean? Standard deviation means how our data values are dispersed from the mean. For example, this is my mean. So I am producing our shaft and customer specification is 100 mm, lower specification limit, upper specification limit is 102 mm, and my mean is in center 101 mm. So all the parts in this category are the okay. But this is the one part which is away from the mean, but this is the part or it is very close to the mean. This part is in between. It is very close, it is far away, but it's in between. So there are, suppose 100 points or 50 points. I need to check dimension of each and every part and I will plot these points on this. Now, a standard deviation means how individual plot or point or part is deviated from the mean. That is called as standard deviation. So it is a Six Sigma concept. Normally we don't cover in 7QC tools, but just for your understanding, standard deviation means how our data points are deviated from the mean. So low standard deviation is always good because then our most of the points are near to the mean. So standard deviation should be as low as possible. If it is a high, then our data points will be away from the mean and it may go outside. So low standard deviation is always good. So there are some formulas how to calculate standard deviation, but we will not go through it. We will use Excel, how to draw standard deviation. Okay. So standard deviation means how my points are dispersed from the mean. That is called as standard deviation. If time permits, we will do the exercise in Excel for the standard deviation. So mainly range, you need to remember difference between maximum value and minimum value. Okay. Now we will start the histogram concept. What is histogram? Histogram is introduced by Carl Pearson. It is introduced in 19th century. But before introduction of histogram, there will be other charts like bar charts, line charts. These were developed by William in 70s. So near about 300 or 225 years back, William Playfair actually he developed the concept of bar charts and line graphs, and the concept of histogram is introduced by Carl Pearson in 19th century. Why histogram is important? Because histogram visualize the distribution of continuous data. I am again repeating continuous data or variable data. Yesterday we saw scatter diagram is used for the continuous data, and hence histogram is also used for the numeric or continuous data. And why it helps? Because it helps to visualize. So I will tell you how it helps. And he introduced the term histogram in 1892. So the term histogram, it is from the Greek words histo and gram. So it is introduced in 1892 by Carl Pearson, and histogram is used for the continuous data, and it will shows us the visual distribution of the continuous data. Okay. As I told you, it is a special type of bar chart. Like Pareto was also bar chart, but it is special type. I will tell you what is that special. So it shows distribution or spread of the data. Spread of the data means this spread. This spread. So that is called as spread. So it shows the spread of the data, and it is a graphical representation. I always tell 7 key tools are visual or graphical representation always of data, where it uses bars, frequency, and intervals. So we will see what bars, frequency, and interval means. So histogram is invented by the Carl Pearson. First time he used the term histogram in 1892. Histogram is used for the continuous data, and Carl Pearson used this histogram because it shows the visual representation of the continuous data, how our data is located, what is the pattern in data. So histogram helps us to understand that patterns. So that is histogram. Okay. When to use histogram? When you need to observe the spread, that is called a spread. So when you need to observe the spread of the data, you can use the histogram. It helps to detect patterns, variation, and we can understand process behavior, how process is behaving. If the spread is more, means our points are going away from the mean. When this process is narrow, this shape is narrow like this. When the shape is narrow like this, mean points are near to the mean. This is the spread, means points are away from the mean. So this process that drawn by red is always good because most of the values are near to the mean. So if there are two histograms, then you can easily say that this histogram is good as compared to this. It is a visually the representation. So to observe the spread, so central tendency means mean. So this is the central tendency, it is a mean, and this is one histogram, this is another histogram. You can easily say that the histogram drawn in red is always good because it has a less spread as compared to the histogram drawn in green. So it helps us to conclude that which histogram is better, how data is spread. Okay. Now, please look at this diagram. So normally histograms look like this. Okay. Normally histogram looks like this. So this is called as class or bin. So these are the bars. So I will tick mark. So this is called as class or bin. So these are called as class or bin. So this is also class. This is also class or bin. So first is class or bin. Okay. Then this is called as interval width. This is called as interval width. This is called as interval width. So these are all called as interval width. And it is the same. Okay. It is always the same. Interval width is same. So this is the called as internal width. This is called as class or bin. This is called as a range. I told you what is range? Maximum minus minimum. Suppose this is 102 mm and this is 100 mm. So range is 2 mm. So this is maximum, for example, and this is minimum. Then the range is max minus minimum. So in histogram, we normally use these four words. First is range. So range is clear now. Max minus minimum is the range. So range is clear? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Interval width is clear. So this looks like a bar, but I will tell you what is the difference between a bar graph and histogram. What is the difference between bar graph and histogram?
For the bar graph, we can, correlate kind of, plan versus actual. But here we are not, correlating. We are just,
Okay.
collecting.
Always remember one difference in bar chart. These two classes or bins, there is a gap. So in histogram, these are connected. So this and this is connected in histogram. In bar chart, there will be like this. So this is one bar will be there. Will be another bar will be there like this. So that is bar graph.
In between
There
two
is a gap.
gap
In
you
histogram, there is no gap. Why no gap? I will tell you. This is one difference. And second is bar is individual. For example, we are 5 people and I ask the salary of each and everyone. So you can write your salary is 1 lakh. He will write his salary is 2 lakhs like that. And one more salary will be more that 3 lakhs. So that is individual. 1, 2, 3. My salary is 1 lakh. Your salary is 2 lakh. But here I will ask what is the salary from 1 to 1.5 lakhs. How many people are there? So there is a, we can write here. So suppose there's 2 people from 1 to 1 lakh. 1.5 lakh to 2 lakhs. Suppose there are 4 peoples. 1.2 to 2.5 lakhs, there are 8 peoples like that. So bar graph is individual, but here that is a range. That is a range, or it is called as frequency. I will explain you in later one. So what is frequency? Frequency means the value here. Suppose this is 8, 6, 5. This is called as frequency. So there are four terminologies or elements of histogram. Range is clear. These are called as classes or bin. This is called as interval width, and these are called as intervals, number of class intervals. So there are 1, 2, 3, 4, 5, 6, 7 class intervals. So in this bar chart, there are 7 class intervals. This is the range, maximum minus minimum. This is internal width, and this is the class bin. Okay. So elements of
Sir,
histogram is clear.
sir, this internal width for 1 to 7 all are equal, sir.
Yes, all are always equal. Okay, there is a formula. I will let you know what is that formula is. But normally 4 components or 4 elements. Range is clear. Class or bin. This is called as class or bin. This is called as 1, 2, 3, 4, 5, 6, 7. 7 are the number of class intervals that is denoted by the K. It is always denoted by the letter K. I have explained in the upcoming slide. The range is always denoted by the letter R. So range means R, class interval means K. These are the classes or bins. This is the interval width. So it is clear. Elements of histogram.
So it's a clear, but here our people has to understand why 2 is bigger than 1 and why 3 is bigger than 2 in the height.
So
That
I will
we
let you know in coming day in upcoming slides. Please be wait. So just this is the structure of histogram. Okay.
yes.
Now suppose this is the runs made by a batsman in last 42 innings of T20 match, IPL T20. Suppose XYZ batsman is there and he scored these runs in T20 match in IPL. So, what is your conclusion from observing this data?
Maximum is 110, minimum is 1.
Num is 0.
Okay.
Num
What
is
are the
0.
other inputs?
Number of matches, sir, number of innings.
Okay, 42. What are the other inputs?
Minimum, maximum,
So
range.
here you are finding difficult because yes, you can identify it because here there are only 42 points. Suppose there are 100 points, 100 matches data. Then it is very difficult to identify what is the maximum, what is the lowest. And it is the runs scored in individual match, like a bar chart. It is one match, match number 120, match number 217, match number 300. So that is like bar chart. For example, in first match, he scored 20 runs. In second match, he scored 17 runs, like that. But normally when we look this data, we don't understand anything because normally people like the visual representation. I will again give one example in next slide. So this is the data. So I told Akash that go to the shop floor and check the diameter of the shaft in mm. So Akash went there and he collected this data. So there are only 50 points. Suppose I told him to collect 75 points. So by observing this value, what do you know? What do you understand? It is very difficult to understand. And hence histogram is used because it is a graphical or visual representation. So how to draw a histogram and how to read the histogram, I will tell you. Because I am telling that histogram is used for the continuous data. Here are only 50 points. Suppose I used 100 points or sometimes 150 data, then it is very difficult to identify. Now let's draw the histogram and it will be very easy. Okay. Before drawing the histogram, let's understand some mathematics. Okay. So number of data points means how many data points you check. Suppose I check 30 points. Here I check more, but for an example, I check 30 points or 30 parts. Okay. Maximum value support is 3.56. For example, here, I don't know. And just example, minimum value is 3.27. Now, before drawing the histogram, we need to calculate something. Firstly, we need to calculate range. What is range? Max minus minimum. What is maximum value? 3.56 minus minimum 3.37. So range is 0.31. Okay. It is clear range. Range is clear or yes or no?
Yes, sir. Yes, sir.
Yes.
I'm just giving. Now we need to identify the class intervals. So whether it is a 7 or 8 or 9, how to decide? How to decide the class interval? There are two methods. One is called as square root of n. N means 30 points. Just take a square root of 30. Suppose it is coming 5.47. Round it. So my 5.47 means 6. So this will be the 6 class intervals. That is one method. So how to calculate class intervals? Suppose your data points are 100. So square root is 10. So means class intervals k is 10. So one method is square root method. Okay. You can use any one method. So this is square root method. Either you can use this or another method is there is a one statistician Sturge. So he has given the formula 1 plus 3 into log of this n, that is called as class intervals. So here I write 1 plus 3 log of 30. Log of 30 is equal to I think 1.47. You can Google it. Log 30 means and 1 plus 3 into log 30 giving is 5.43. Almost near to the same. So you can say that I will use 6 intervals because I will round it off. So I can say that I will use 6 intervals. So I have told you that before drawing histogram, you need to calculate first range. Range is very simple. Max value minus minimum value. That is very good. How to calculate class intervals? Take the square root of n. So my points are 100. Then 10 is the class interval. This is one method. Another method is Sturge formula. 1 plus 3 into log n. If it is 100, then 1 plus 3 into log 100. Whatever it may come, 2 or log 100, I don't know. Then 1 plus 3 into like 2. That's 7 intervals like that. So this is one formula to calculate the class interval. Otherwise, you can refer this diagram. This is a very simple diagram. Do not calculate anything. Do not calculate anything. If your number of data points under 50, either decide class interval between 5 to 7. You can say 6. I will take an average 6. So when the data points are 50 to 100, 6 to 10, you can select 8. When data points are 100 to 50, 7 to 15, you can select 12 like that. So either you can use this ready-made guideline or you can calculate by using the formula. So any method you can use, correct? Got it?
Yes, sir.
Yeah.
Okay, now just wait. I will explain how to draw a histogram and it will automatically give your answers. So range is clear. Max value and minimum value. Class interval is the square root of data points, or by Sturge formula 1 plus 3 into log of that, or interval width is equal to range divided by. Now we need to calculate this internal width. So how to calculate internal width? Formula is range divided by number of class interval. Here range is 0.19. So I draw the 0.19 divided by class interval is 6. So I draw the 6. So the range interval width is 0.031. So this is just mathematics before completing, and we can do it in Excel, but most of the times it is very easy to draw in Excel, but most of the times we are not aware of the basic terminology and we forget the basics. So I always emphasize on basics. So calculate range, calculate class intervals by square root of n, or you can use this ready-made table. Okay. Now we will go to the Excel, how to draw the histogram. Okay. Now I will open Excel file. Is my screen visible?
Yes, sir. Yes, sir. It's visible.
Yes. Yes.
Yes,
Okay.
sir.
Now we will draw the histogram in Excel and then we will go to the control charts. Okay. Okay. Now suppose I told Akash that check the diameter of shaft and check the diameter of 75 parts. Always remember, for drawing histogram, ideally you should check at least 30 parts. So not less than that. First is it should be used for the continuous data. And second is you should at least check 30 parts. As per statistics, you should not conclude. So at least you should check 30 parts. Okay. But maximum 50 or 100 is always okay. But minimum you should check 30 parts. Suppose Akash checked 75 parts. So and he wrote down what he observed the dimension. So Akash checked 75 parts and he came up with this only 2 columns to me. So Akash told me, sir, this is the data. Now I would like to teach histogram to Akash. I will teach him how to draw histogram. So Akash came with only these 2 columns, diameter of shaft and serial number. Okay. Now I will ask first question to Akash. Total data points. So I can count here by Excel. I will use that formula as well. Count. So total data points are 75. This is the count formula, or we know that the total data points are 75 because Akash told me that he collected 75 points. Okay. Now I told Akash, please tell me the maximum value. How to do that? I will use again the formula is equal to max. I will select this, then Control Shift arrow down, bracket complete, enter. So maximum value is 3.63. I told Akash that first count the data points by using Excel. He counted. Then I told Akash now calculate the maximum value. Now I told Akash now calculate minimum value. I told the formula to Akash is equal to minimum. So 3.30 is the minimum value. Okay. So Akash give me two values, sir. Maximum value is 3.63 mm. Suppose the diameter in mm, and minimum value is 3.30 mm. Okay. Now I already taught Akash how to calculate range. It is very simple. Akash told me that maximum value minus minimum value is the range, sir. Okay. So range is 0.33. Okay. Now I told Akash you can calculate number of intervals. So Akash is very smart. He know how to calculate. He will just take a square root of 75. 8.60, round method is 9. So he will tell me that, sir, I will use the 9 intervals. 9 intervals. Or you can use the Sturge formula. But here 9 intervals, or you can refer this. As I told you, either you can square root of n or Sturge formula, or you can use the ready-made. For example, my points are 50 and 100 in between. So you can select 8 or 9. It is okay, no problem at all. So it is 50 and 175. So either you can use 8 or 9. It is okay, no worries. Okay. Now I came to Excel again. So number of intervals are 9. Okay. Now I need to calculate interval width. Interval width means what? This interval width, and it is always same in histogram. Okay. What is interval width? What is the range? I know it is a 0.33 divided by number of intervals, suppose 9. So 0.037 is the interval width. Okay. Bus, that's it. So I told Akash, now you can rest. And please sit with me. I will tell you how to draw histogram in Excel. Okay. So I calculated the maximum value, minimum value, range, number of intervals, like that, interval width. Now, number of class intervals. How to do that? Here, write down your minimum value. Minimum value is 3.30 is my minimum value. Very good. Now, this minimum value plus your interval width, you need to add. So I will put $sign here. So it is a 3.34. Okay. And I will drag. Okay. So I need to check whether I have covered the maximum value here. Yes, maximum value is 3.63. If it is 3.61, you can drag it one more row. But here it is covered maximum value, so I can stop here. So I told Akash, now number of class intervals, put minimum value here and just add your interval width, and this will be the number of class intervals. Okay. Now, number of class intervals means, sorry, now we need to calculate frequency. Frequency means for how many times 3.30 occurs in this data point. For how many times 3.34 occurs. For how many times 3.37 occurs. What is the formula I use is equal to frequency. Okay. Data array, it shows data array. Data array means the diameter of the shaft. So I selected this data array. Okay, I selected this data array. Then comma, and bin array means number of class intervals. Okay, so it is 2. What does it mean? 3.30 came 2 times. 3.34 diameter came 3 times. We need not to calculate manually. Excel is giving us 3.37 came 3 times. 3.45 came 10 times, like that. Okay, so this is the frequency. Very simple. So now I need to draw a bar chart. So just select this up to this point. Insert bar chart. Okay, this is our histogram. You can name it. But we need to, as I told you, what is the difference between bar chart and histogram? There is no gap in histogram. So we need to reduce this gap. So click on any bar, format data series. Gap width, you can make it 0. Very good. So this is your histogram. Now it should have the data labels. So these are the data labels. I can make bigger. So I will draw the lines. Now I will do format. shape outline, I selected a black, and suppose I selected shape outline more weight, suppose like this. So this is my histogram is ready. Now here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to change that. I need to see these values here, 3.30, 3.34. So I will just collect here, select data. The range, I need to put this range. Okay. Okay. So these are my values. Okay. Now, somebody was asking me, what is that 3? What is that 3? What is that 6? What does it mean? 3.30 diameter. There are 2 jobs I found which are having 3.30 diameters. I found 3 jobs having 3.34 diameters. I found 3 jobs in between 3.34 and 3.37, 3 jobs. Sorry, 3.41 jobs, 6 jobs. 3.45 diameter, 10 jobs. 3.48 diameter, 23 jobs. 3.52 diameter, 10 jobs. 10 jobs, 6 jobs, like that. So now just paste this diagram in front of this. So this is the data earlier. Now when you paste it here, it is very easy. Here Akash was giving me this data. It is very difficult more to interpret. Now I can easily interpret. So yes, 3.30, 2 jobs, 3.34, 3 jobs, 3 jobs, 6 jobs, like that. So that is the benefit of histogram. We can easily see that most of the time 23 jobs is of 3.48 diameters.
Sir,
So
here I have
3.48
one
diameters.
question.
Yes.
In between that, sir, there are the 3.49 also mentioned in the data, and that where it is reflected. So because that value is not reflected in this chart.
Actually, what histogram is doing, if it's 3.49 na, so normally it is came here 3.48 and in between 3.52.
In the range.
In this area it is taking. What does it mean? 3.48 and 3.52. These values between 3.48 and 3.52 is these 23.
So we need to consider in between two internal that values are
Yes.
appearing in that
Yes.
that above that area
Yes.
only.
Yes.
Okay, sir.
Okay. So got it? Histogram.
Yes, sir.
Very simple. Always I remember this is suppose I draw the Virat Kohli runs. Instead of looking at this data, I will not now I could suppose these are the runs. Suppose it is 10 to 0 to 10. So Virat Kohli normally outs in between 0 to 10 2 times. Suppose it is 11 to 20. Normally he scored three times scored between 11 to 20, like that. 20 to 30, he scored 3 times runs between 20 to 30, like that. 30 to 40, he scored 6 times. Now 40 to 50, 10 times. 50 to 60, 23 times. Like Tendulkar was out in between 90 to 100 for the how many times?
23 times.
Sachin
Sir, one
Tendulkar
more
was
question.
out
Sir,
between
one doubt,
90
sir.
to 123 times, I think. 23
Sir,
or
one more
21 times.
question.
Yes.
There is a 3.63. It's a value. It's the chart. It will be one time, but is there the chart? There is no mentioning.
Why? Because it is coming normally what histogram does now. Normally 3.63 minus some value it counted here in 3.59 and hence it is a 0. Normally
So
what
it's
histogram says, suppose there are overlapping now, then normally 3.63 it considered in this 3.59 to 3.63.
okay. It's calculated in the interval.
Yes. And suppose value was 3.66 now, then it is calculating 3.63 to 3.66. Suppose it is 2 value,
One
then there
time.
will be a graph of 2,
Okay.
like that. That
Okay.
is the, okay, histogram is clear.
Yes, sir.
Yes, clear.
Now we will move to the last 7 QC tool, and it is a control charts. As I told, it is a very vast tool. We will not cover entire because it is taking 4 hours to complete. It is a separate session on control charts, but we will go quick through. So history, Walter Shewhart, he was the father of statistical quality control. and he invented this tool in 1920 in Bell Laboratories, USA. At that time, there was a need to reduce the frequency of failures and repairs, and hence he invented this control chart. Okay. Now, before going to study the control chart, some concepts we need to understand. First concept is the difference between common cause and special cause. Can anyone tell me what is common cause, what is special cause?
Common cause means it's occurrence continuously.
Suppose one person who is speaking.
I mean,
Yeah, my name is Shiva.
Anyone.
Shiva. My name is
Shiva.
Shiva. Yeah.
Suppose I told Shiva that please make your sign 50 times. So when I check the sign number 1 and sign number 50, will it be exactly same?
No, sir. It will be not same.
Why? Because you are only signing, I am not signing. The pen is same, paper is same, your hand is same, you are the same person, the same conditions, the same temperature, you are sitting in AC in 25 degrees Celsius. Everything is okay, but why your sign number 1 and sign number 50 will not match?
There will be a common, causes.
Because that is the limitation of body. So we cannot avoid the variation. So that variation which we cannot avoid, that it causes are called as common causes. We cannot avoid, that will be not exactly same. But suppose when Shiva is signing and I give him a jolt, and hence because of that his sign become entirely different. Then Shiva can tell me why this sign is entirely different, because he can tell me, sir, because of you, because you obstructed me and hence this sign is different. Shiva can easily tell why this sign is different because of me. But even though I didn't disturb Shiva and he's sitting in AC room and he's signing 50 times, and but sign number 1 and sign number 50 is not matching, and when I ask Shiva why there is a difference of sign, so he will not able to answer, because that is the limitation of his body. His body, his hand cannot produce the same signs. Suppose 1,000 signs he need to sign. No. So that cause which is inherent, which we cannot eliminate, that cause is called as common cause. Okay. Normally you check your blood pressure.
Yes.
Ideally what it should be? Suppose 80 and 120. Suppose I check the blood pressure of Shiva. And 80 and 110, so reading is 90 and 130. Okay. Again, next day I will check the BP. Will it be exactly same 90 and 130?
No, sir.
No, there will be maybe 88 or 128. And Shiva is also not able to give the answer. Sir, nothing has happened, sir. Even if I check BP after 3 hours now, there will be some difference and Shiva will not able to tell, because this is the body. So there will be some difference. Always remember, two parts in the words are never identical. Even though it looks same, there will be something is different. Something is different. Either their texture is different, something will be different. Either there will be hardness will vary, from a little variation will be there, but there will be a variation. No two parts in the word are identical. So Shiva will not able to tell why his BP is, earlier it was 90 and 130, why it is now 89 and 129. No. Suppose if I check the attendance of Shiva, at what time Shiva logged in for the session for the 5 days. And I came to know that on one day he logged in at 7:31, another day he logged in 7:30, third day he logged in 7:32, fourth day he logged in 7:28. So there will be some variation. So these are called as common causes. So what is common causes? It is inherent variation. It is a natural pattern. It cannot be eliminated. The signs will be, there will be some difference. That is called as common causes. Okay. And we cannot solve the common causes, or operators or supervisors cannot solve the common causes problems. Management intervention, high technology is required. And even though high technology, we will not be able to eliminate the variation. We will able to reduce the variation. After practice, Shiva will reduce the variation between the sign, but to make exactly same sign number 1 and 1000 sign, it is very difficult. So common causes means these are called as inherent variation. It is called as natural variation. Okay, that is called as part to part variation. For example, this is called as common cause. So it is clear common cause cannot be eliminated. Management intervention is required. It is the natural pattern. It is the tendency of body. We cannot eliminate. So what is special cause? Special cause means not natural. Something has happened, right? Suppose Shiva is traveling from a company, and because of there is some tree in the road, and because of that tree, he joined today's class at 8 instead of 7:30. So he can tell, sir, why 8? Because there was some problem. That is called a special cause. Something special is happened. So that is called a special cause. Suppose Shiva's BP is 160, for example, sudden shoot, and I ask him why 160 today. So there is some accident of his close friend, for example, and because of that, BP shoot up. So he can tell because of that incident, my BP is high. So that is called a special cause. It is not a natural variation. It is occurred because of some of the incidences occurred. So that is called a special cause. And we can eliminate the special cause, but we cannot eliminate the common cause. For example, when I abstracted Shiva, and because of that abstraction, his sign came different. Okay. But Shiva can tell because sir abstracted me and my sign is different. So special cause means why your sign is entirely different? Because sir abstracted me, or he can prevent that cause. He can take a bodyguard, and bodyguard like a prime minister or chief minister, and we are not able to touch the Shiva when he was signing. So special cause can be eliminated by various methods. Common cause cannot be eliminated. It is the inherent variation. It is the natural variation. So these two concepts are clear, common cause and special cause.
Yes, sir, it's clear.
Common cause is inherent variation, natural variation. Special cause, it is can be eliminated. It is because of one of the event occurred, and this problem supervisor can solve. Here no management intervention is required. And as per Mr. Deming, what Deming said, Deming was saying that 85, as per Deming, 94% is the contribution of common causes, and 6% is the only contribution of special causes. So what Deming was saying to the management, so common causes is always management solve. So Deming was saying to that operator can solve only 6% of problems. You should solve 94% of the problem, because 94% of the problems are because of the common causes, and only 6% are because of the special causes. That was Deming's observation, but in general, it is said that 85 to 95% variation is because of the common causes, and 5 to 15% variation is because of the special causes. Means most of the variation is because of the common causes, and hence Deming was always saying you cannot, operator is not responsible. You, management, is responsible, because 85 to 95% is your job, and 6 or 5 to 10, 15% is the operator job. So that is the difference between common cause and special cause. Okay, clear? Now, what is specification limit? Who gives specification limit?
Requirement of the
Customer.
particular feature.
Customer.
Requirement
Customer
of the
gives the
particular feature.
specification limit. Okay. So we will not. And what is the control limits? Specification limits are given by the customer, but control limits are to be calculated. There are some formulas to calculate control limits. We will see one chart. For one chart, we will calculate the control limits. But basic difference is specification limit is given by the customer or management sometimes, and we need to calculate the control limits. Okay. Specification limit is the voice of the customer, because customer is giving the specification limit, and control limit is the voice of the process. So normally I cover this in SPC, but only remember one thing: specification limits are given by the customers, and control limits we need to calculate. And in control charts, we use the control limits. In control chart, we never use the specification limit. Then why control charts are used? The control charts are used to detect whether there is a presence of special cause. I again repeat, why control charts are used. So control charts is a 4-hour topic, but we are just giving the basic information. Why control charts are used? So your first answer should be, I use control chart because I need to check whether there is a presence of special cause. And if there is a presence of special cause, you can easily say that your process is not in control. I am again repeating, what is control chart? Control chart is nothing else but it is a tool which tell, hello, please be on mute. Control chart is a tool which tells us that whether there is a presence of special cause or not. And if there is a presence of special cause, we can say that process is not in control. Okay. But how to identify whether there is a special cause or not on control charts? I will tell you later on. Okay. But special cause is clear. Special clause and common cause clear.
Yes,
Now,
sir.
why control chart is used? Your answer should be control chart is used whether special cause
Presence
is
of
present in
special
my
cause.
process or not. Pardon?
Yes.
Clear, na?
Yes, sir.
So, in one sentence, you should tell, I am using control chart because I need to check whether there is a special cause present in my process. And if there is a special cause is present in my process, my conclusion is that my process is not in control. Okay. Now we will see how control chart looks like. That is called as elements of control chart. Okay. So these are the elements of control chart. It is a basic framework. So this is called as one scale, 90, 100, 110, 120. That is called as scale. So what is part number one? Scale. Scale means this scale measurement. 90 mm diameter of shaft, 100 mm diameter of shaft, 110, 120, 130. So this is called as scale. Point number two, this is called as upper control limit, called as UCL, and this is called as lower control limit, LCL. I again tell you, specification limits are given by the customer, but control limits are to be calculated by using formula. We need to calculate control limits by using formula, and I will tell you how to calculate control limits for one of the control chart, because there are lots of types of control chart. We are not going to cover everything in detail, but these two lines, these are called as upper control limit and lower control limit. Okay. Point number three, this is called as center line, mean. You can say the mean. This is called as mean, center line. Okay. Now this is point number four, is very, very important. When any of the point is out of these two lines, then you can say that presence of special cause. And you can declare that your process is out of control. I can tell Akash, your process is out of control. Sir, why you are saying this? My process is in control. No, I have checked your data. I have plotted the control charts. And by plotting the control charts, I came to know that point number three, it is out of the specific, control limit. It is either on this side or either on this side. If it is on this side or on this side, if any one point is going out of the UCL or LCL, you can declare that your process is out of control. Now, please hold that process and please check what is happening. And fifth is called as event log. What event log means? You need to keep the data. For example, in first shift, new setup, insert IC27 is changed, material is changed from this lot to this lot. And when there is a special cause, suppose part number 3 at 9 a.m. So you can check at 9 a.m. what has happened, whether operator has changed, whether coolant has changed, whether raw material has changed or that. So you can predict that This process is out of control because one point is going away from the LCL or UCL. So this is how the control charts looks like. So we will just understand this concept. We were not going to detail, but this concept is clear. Control chart means each and every part. For example, at 9 a.m. I checked one part and found the diameter is 115. Second part, after suppose 30 minutes, it is found that 100 and for example 15. Third part, I found that it is like this. So I calculated all the dimensions, and when I plot the control chart, I came to know that this part is at this dimension, or this part is out of the control limit. So my process is not in control. These are the elements of control chart. I will again repeat: scale, upper control limit, lower control limit, central line, out of control, and event log. Okay.
Sir, here I have one question, please. Can you
Yes.
that just question is that out of control process is only for that part number 3, yeah, or total whole system is out of control. What we can say
No,
about
no,
this?
only that part number 3, but you need to stop that here. Otherwise, it will again go on this side. If you not stop here now, it will again go on this side. For example, if your BP is always increasing slowly, 80 to 120, 85 to 130, 90 to 130, then you are saying, yes, my BP is okay. Okay, because above 100 is a problem. It is increasing, means you need to study what is happening in my body. You need to study what is happening, why it is coming on this side. Again, it will go here, maybe. Suppose after this point, again, he will go here. So you need to check what is happened here. And it is for that particular point.
Okay, sir.
Here you need to study what has happened exactly. At 9 a.m., I checked this part. What 9 a.m., what was the process parameters? Who was running the machine? Whether that operator was on lunch break or tea break or snacks break, and another operator is running the machine. So you need to check what has happened there. Clear?
Yes, sir.
Okay. So these are called as elements of control chart. And as I told, Deming is saying 94 causes a percent is because of the common cause, 6% are special cause. So management is responsible for this, and only responsibility operator is 6% or 10 or 15% maximum. Clear? So control chart elements are clear. Elements are clear. Why control chart is used? The only use of control chart is to detect the presence of special cause. And I came to know that if special cause is present, my process is out of control. Clear? Okay. Now we will go through. Are you aware about the sample and subgroup?
No, sir.
Okay. Now I will tell you in 2 minutes. Suppose you are a Cadbury manufacturing company. Okay. And Cadbury manufacturing, and you are manufacturing the Cadbury of 100 grams. Just imagine you are calculating, producing the Cadbury of 100 grams. So as we saw, two parts are never identical. Sometimes I feel check the weight and I will find that 100.1. Sometimes it will be exact 100. Sometimes maybe 100.12. Sometimes it will be 100.15. Got it? Now, what I will do, what is sample and what is subgroup? Suppose my line is running. So I am producing, suppose 15,000 Cadbury's in a day. So I am producing 15,000 Cadbury. Is it possible to check me weight of each and every Cadbury manually?
Not possible.
Not possible. So what I tell Akash, at 8 a.m. go there and just pick the 5 Cadburys. At 8 a.m. he will pick the 5 Cadburys, and please note down the weight of 5 Cadburys. He will pick the 5 Cadburys and note down the weight. Okay. I will tell Akash, go again at 9 a.m. Again take the 5 Cadburys and please wait. So Akash is taking the Cadbury and waiting. It is on lower side, for example. Again, I tell Akash, go at 10 a.m. Again, take the 5 Cadburys and check the weight like that. So now I will explain this slide. So I have produced, suppose 15,000 parts or 15,000 Cadburys. Okay. But on every hour, I am picking 5 Cadburys to check the weights or to check the dimension. If it is a part, I am taking the dimension. So that 5, at 1 hour, I am checking that 5 parts or 5 Cadburys. That 5 is called as subgroup size. And in total, I have checked 100 parts in a day. That is called as sample size. Means I can tell my manager, total you produced 15,000 parts. Okay, sir, but I checked 100 samples and subgroup size is 5. And Akash explained me, sir, subgroup size is 5 means every hour I picked 5 categories. Okay. When he pick 3 categories, then subgroup size will be 3. When you will pick 4 categories, subgroup size will 4. Correct? So sample size means in a day, how many samples checked by the Akash? 100 samples checked by the Akash. Total number of parts produced 15,000. And what is the subgroup size? So Akash asked me, sir, what is subgroup size? I told Akash, at a time, how many category you are picking? Akash is saying, sir, every 1 hour I was picking 5. So that is called a subgroup size. Clear? So sample size and subgroup size concept is clear.
Sir, is it like batch size in mass production? We are checking, making batch size also. This lot size and batch size are similar to that.
Actually, lot size is different. Here, for example, I don't know what is your production, but here, suppose there is a homogeneous mixture, paint I am preparing, then at that time,
Parts are only machine parts only, but equal type of parts in first lot. Actually, we are also doing sampling. No, so for suppose for 5 parts, if it's simple, we are checking 3. Then if it is 50, then we are checking 20. Like that way, we are just giving this group and subgroup like that.
Okay. No, but every hour you are picking 3 or 5 or not like that.
Sir, when the process was completed, at that time only we are picking.
Okay. Then it is a subgroup size. Subgroup means what? Suppose I want to observe my process and I decided that I will not collect only only 8 AM data. No, I will tell Akash that entire 3 shift data I need because operators are changing. So I will capture all the variations in a day. So systematically, I told Akash that every at 8 AM, 9 AM, 10 AM, collect 5 categories. So when he is collecting 5, that is called a subgroup size. And in 20 hours, suppose my shift is running, he checked 100
Sir,
samples. That
telling
is
this
called sample
product
size.
will be this 15,000 parts will be of same category or different category?
Same category, same category.
Oh, okay, sir, I understand.
Okay. So I'm just giving an example. Okay. Why this is concept example, I will let you know in next slide. Okay. Now we will see the control charts. So there are 2 types of control charts. One is variable and one is called as attribute. Okay, variable means variable data. We can measure on continuous scale and it is attribute. Yes, no, go, no go, head, tail, pass, fail, like that. So there are 7 types of control charts. We are not going to see all the control charts. I will just telling you there are 2 types of control charts, variable and attribute. In variable, there are 3 control charts. One is called as X bar and range chart. Second is called as X bar and ES chart. And third is called as individual moving range chart. Okay. So this is for the variable. So if there is a dimension, weight, category weight, dimension, then we are using either one of out of 3. I will tell you when we are using IMR, when we are using X bar, when we are using X bar S chart. So when there is a variable data, weight data, dimension data, I use either one of the chart. Out of 3, either use one of the chart. Okay. When there is a attribute data, okay, not okay, go, no go, pass, fail, head, tail, I will use 4 charts. P chart, NP chart, U chart, and C chart. Okay. This is the only slide you need to remember. And henceforth, you need not to remember in 7 QC tools. When there is a control chart training, I can explain in detail. But what is control chart? It is used to detect the presence of special cause. Very good. Okay. When you say your process is out of control, I will say my process is out of control if there is a presence of special cause. What is special cause? We learn. What is common cause? What is special cause, right? Then we learn what is subgroup, what is sample. Okay. Now, what are the types of control chart? Variable and attribute. In variable, there are 3 control charts. And in attribute, there are 4 control charts. Okay. Now, this is the last slide I will explain, and then we will take one example of IMR chart. So, how to select a control chart? So, it is not expected in 7 key tools. It is a part of 6 Sigma, but there is a time, so I am explaining you how to select a control chart. So, first you need to ask one question. This is a process flow chart. Flow chart we do. First, whether data is continuous or discrete or attribute. Suppose it is a continuous data and suppose it is discrete data. Okay. So when there is data is continuous, so I will ask the question, how much is the subgroup size? If I am taking a subgroup in between 2 to 9, then use X bar R chart. When I am taking subgroup greater than 10, use X bar S chart. And when I am taking only one part, not 5 part, only one, that is called as IMR chart, individual moving chart. So I would just listen. When you are selecting control chart, first question is you need to ask whether it is a continuous or discrete. Answer is continuous because category weight we can measure. Okay. Now what is subgroup size? Akash told me, sir, I am using 5 subgroup size. So which chart I should use?
Bar X bar R chart.
X bar R. And this chart is famous in industry. X bar S chart people normally doesn't use because it is sample size subgroup size greater than 10. That is very difficult. Normally we take 5, 3 or 4 samples. So normally in industry X bar chart is mostly used. Okay. And when discrete data, I ask two questions, defect and defective. What is difference between defects and defectives?
Sir, defect is a entire product. If in that, if there is any different kind of dimensional deviations or problems or visual issues, then those are all defects.
Yes. So for example, I have a pen and that pen is 3 problems. One is that ink is coming out of that. Second is cap is not, I'm not able to press the cap. And suppose third is that tip is broken. So all that defects observed in single pen. So my rejection is one pen I rejected. So that is called as defective. This is the defective pen, but it has 3 defects. So that is the difference between defectives and defects. Defectives means in one part there can be a multiple defects. So in one pen there may be 3 defects. But when I will count defects, I will count 3. When I will count defective, I will count one pen defective. But anyone ask me how many defects in one pen, I will tell 3 defects. Clear? So when you are collecting the data on defects, you need to use U and C chart. When you are collecting the data on defectives, you need to use P and NP chart. Okay? So forget about this. It is just a Six Sigma part, but I just told you how to decide a control chart. Now I will decide which chart should I use. Suppose it is continuous data and sample size between 2 to 9, I will go X bar chart. If it is single sample, I will go to IMR chart. If the sample subgroup size is greater than 10, I will use X bar chart. If I am counting defects, I will use C or U. When I am counting defectives, I will use P and NP. But when I will use U and when I will use C, when my sample size is constant, means in a day, in a month, normally I check 100 samples per day and I want to calculate defect, but my sample size is constant, 100 samples per day. I don't know whatever production, whether it is a 15,000, 16,000, 17,000, 12,000, I use 100 samples. If sample size is constant, you should use C chart. And if sample size is not constant, you are varying the sample size, you can use the U chart. Suppose you would like to do analysis on defectives. If your sample size is constant, answer is yes, use NP chart. If sample size is not constant, use P chart. So this is the diagram how to select a control chart. Okay. So is that clear? This part of control chart we will extend by 5 minutes. At 9:05 we will finish today. Okay, 9:05 or 9:10.
Sir, this
But that
sir, how we will understand what is U chart, C chart, P chart, and P chart?
yes, I can show you, but it will be too
Whether
much
any
statistics.
standards is there for this U chart, C chart, P chart?
I will show you. But only thing is, first my question is, have you understood what is special cause, common cause? Yes or no?
Yeah. Yes, sir.
Okay, that is sufficient. Have you understood the subgroup size and sample size concept?
Yes.
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 Have you identified the elements of the control chart? Center line, UCL, LCL?
Yes, sir.
Yes, sir.
Answer is clear. Yes. So this should be
Control
clear.
point, special cause.
Then this should be clear, and then this should be the clear variable type, attribute type, and Subgroup size is varying, then when 2 to 9 use this chart. So these are called as subgroup size, and this is called as continuous and discrete. So how to select a control chart? This is the graph. Normally we cover this in Six Sigma. Okay. Now we'll take one example of IMR chart. Just I will go through the slide. Suppose when to use IMR chart, sometimes I am taking 5 categories, but sometimes I am doing a destructive testing. Then it is very difficult to take 5 samples. I will take only 1 sample. Or there is a soap company, chemical company. They are making the liquid, and that is liquid is homogeneous. So there is need not to take different samples because mixture. Then you can use IMR chart instead of X bar R chart. When hello, please be on mute. IMR chart used when there is a destructive testing, and when you are taking only 1 sample, or either mixture is homogeneous like soap industry. So you can say that, sir, need not to take a mixture sample from each and every hour because our mixture is homogeneous. Then you can use IMR chart. Okay. So we will see this example and then we will stop. Suppose a chemical company monitors the concentration of acid and using IMR chart, and these are the concentration values. And my manager asked me a question, Kiran, tell me, is my process in control or not? So this is the values observed, and he is asking me whether my process is in control or not. So I will write down all these values, 8, 8.5, 7.4, like that. I will write down the moving range. Moving range means this minus this, this minus this minus this, like that. So that is called as difference between these two, difference between these two, difference between these two, difference between these two. So this is called as moving range. Okay. So these are my X values. These are my moving range. IMR chart. IMR means individual moving range. Individual means X and MR means moving range. So when I take the average of this, that is called as X bar. When I take average of this is called as MR bar. Okay. So I will again tell you, this is the average of X. This is the average of MR bar. Okay. Now there are some formulas. So I will just tell you how to calculate that. So you can go through the internet and check the formulas. It is not part of 7QC tools, but I am explaining you. It is a part of SPC or Six Sigma. IMR chart. So this is the formula. UCL. I told specification limit is given by the customer, but control limits are to be calculated. Formula is X bar plus E2R bar. X bar is, for example, 10.57 is the X bar. So I put the X bar is 10.57. What is E2? This is the standard. This is given by the AIEG manual. When your sample size is 2, you should use 2.660. Our sample size is 1. Then you can use this 2.660. If sample size is, subgroup size is 3, you can use 1.773. Now my subgroup size is 1, but here not mentioned 1. So I can take of 2. So X bar 10.57 plus E2. E2 what is 2.660 here, 2.660 into R bar. What is R bar? R bar, that is called as MR bar, means called as R bar. 1.283. So 1.283. So total is 13.98. That is called as my upper control limit. So I will draw a line at 13.99. Very good. What is the lower control limit? X bar minus E2 R bar. X bar value is 10.57. E2 is 2.660. R bar is 1.283. LCL is called as 7.16. Okay. And when I check the data, when I plot the run chart, I came to know that 1 point is out of the UCL. So I tell my manager, sir, our process is out of control. Our process is out of control. So these are the some formulas. So you can check. So it is not expected in 7QC tools, but just understanding the concept of control chart. Okay. So now I will just go through all the slides. It will be a final recap. So please be with me and I will share the material tomorrow or the it is clear. Hello, is it
Yes,
clear?
sir.
Yes.
Yes, sir.
Then transformation of Japan, history of 7QC tools, introduction to PDCA cycle. So there is no time. So you can check that PDCA cycle. It is not part of 7QC tools, but or otherwise I will show you a slide. Types of data clear.
Yeah.
Yes, absolutely clear.
Basic statistical definitions: mean, median, mode, range.
Yes, sir.
What is problem? What is problem?
Unexpected.
Undesired result or gap from
Undesired
standard.
Undesired result.
How to describe a problem? Which tool we are using to describe a problem? 4W.
4W1.
4W1H we are using for describing a problem. Please be on mute. Then we learn check sheet clear.
Yeah, check sheet.
Yes, sir.
Then
Data collect.
Pareto diagram.
Pareto
Clear
diagram.
Pareto.
Yes,
Yeah.
sir.
Cause and defect.
Yes,
Yes.
sir.
Yes.
His own background.
Histogram.
Sugar.
Scatter diagram.
Yeah.
Flow chart.
Yes.
Stratification
Yes, sir.
and control chart.
Yes.
So control chart, I am again telling you why it is used. Control chart is used to detect whether there is a presence of special cause. And if there is a presence of special cause, you can say that our process is out of control. Clear? Secondly, I told there are attribute and variable control charts. We understood the concept of sample size, subgroup size. What is IMR chart, X bar chart, X bar S chart, and C chart, U chart, P chart, NP chart. When defectives we are counting, use P or NP, and when defects, use C and U. Then we saw the specification limit is given by the customer. Control limit we need to calculate by using the formula. I show you example of IMR chart, how to calculate the formula. And then Akash told me that process is out of control because sir, one point is going out of the control. So there are multiple formulas of the control charts you can check, but it is not expected at this level in 7QC tools. Okay.
Okay.
So friends, once again, I am putting my mobile number. Please ask me any question and thank you. So this will be the last session. So
Sir,
thank you.
Sir, can
Yes.
you give some brief of PDCA cycle? Actually, for what we are doing that basically?
I will to tell you. So this is the PDCA cycle. When you want to improve anything, always use the PDCA cycle. And when you want to sustain anything, use the SDCA cycle. What is PDCA? Plan, do, check, act. For example, if your 5-year score is 50 and you would like to reach to the 70, your 5-year score. When you want to improve anything, use PDCA cycle. So my score is 50 and I would like to go to 70. So first step, I should do plan. So I will conduct initial audit. What are my observations? I will decide the action plan. Why my score is 50? Why I'm not getting 70? So why there is a gap, whether I am lagging in 1S, 2S, 3S like that. So that is plan. Oh, that is called as plan. So I am making a plan on paper. I will making an action plan on paper.
Right.
So these actions I will take. That is called as plan. Then D stands for do. Now you need to implement those actions. So that is stands for D. What you have planned, what you have written on paper, you need to implement. That is called as D. PD. C means check whether you are achieving the results or not. So I implemented this action and my score is improving or not. If my score is not improving means my actions are not effective or either I have selected wrong actions. Then I am again A for act. I need to act again because my score is not improving. My health is not improving. My weight is not reducing. Again, I will check whether my plan is not correct, whether my actions are not correct, like that. So PDCA cycle is used to improve anything. It may be your weight, it may be your 5-year score, it may be your health, anything. That is called as PDCA. Clear?
Yes, sir. Yes.
You
Thank
can
you.
Google it out. So once again, I will stop share. So now I will once again write down my mobile number. Please ask and please give me feedback as well. This is my mobile number. This is my WhatsApp number as well. So thank you. I will share the training material as well. So please give me your feedback. Was it a value addition or not?
Sir,
Yes,
of
yes, sir.
course, it's to our
Yes,
value addition. I had a good experience with you.
100%.
Yes, sir.
Yes, yes. I will give training. So thank you once again and good night. And sorry, there will be 5 minutes late because I thought that concept should be clear to all of you.
Sir, I have a query, sir.
Yes, yes. You are most welcome.
Yes. Sir, will I have to appear in any examination for the certification process after the class?
No, 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 no. You will get certificate.
Oh,
Certificate gets sir online or sir hard copy sir.
No, no, no. Actually, you can contact admin. They will tell you. It will be a, I think, soft copy.
Hard copy is not provided.
Sir, is there any particular training on SPC or else control charts in further days?
So I will check because when there is will need, I will deliver. Because as I told now, control chart, it is at this level in 7QC tools, it will be too much heavy.
Yes.
Because it is a very much again formulas. I will need to calculate this everything. So, but
So
if you are interested, then we can discuss.
yes, sir, I'm interested to know then about the control charts. But as you told, it will be like 4 hours, but it will be in a single day or else 2 days.
No, no. Normally, I never conducted for MSME, but normally in my previous organization, I was conducting 4 hours in a consecutive day because we need to start with the common cause concept, special cause concept, then that's subgroup size, then specification limit, control limit, and then we are explaining what is control chart, why process should be in control, and then we are using the types of control chart, then how to draw the control charts on Excel by using the formulas. So it will take some time. So it is normally 4 hour session like that.
Yes.
In Six Sigma module, a control chart is covered, no, sir, fully.
So control chart, yes, there are lots of tools in Six Sigma. So control chart is one of them.
Okay, sir.
So
Thank you, sir.
according to
Thank you so
you,
much.
Yes,
hello.
yes,
So
please.
according to you, what certifications we can do further for doing Excel in this quality assurance, quality control field?
If I will suggest you to go for the Six Sigma or Lean certification, and also Kaizen certification is also good because Kaizen is for everyone. So Kaizen, Lean Six Sigma, Green Belt, Yellow Belt, or Lean Practitioner. There is some session on Lean manufacturing as well. So I'm also trying with MSME. If we get that opportunity, then we will cover that as well. One more training is called as QC Story. QC Story is a Japanese approach. It is a 7-step approach. So QC Story normally we explain the 7 QC tools fishbone there, as well as the how to define a problem, 3G concept. But QC Story is a concept developed by the Japanese. There are 7 steps to solve any problem. So that training is also good. So QC Story, Six Sigma, Yellow Belt, Green Belt, Lean Manufacturing training, Kaizen training, root cause
Sir,
analysis
what about
training.
VDA 6.3?
Sir, is there any training on
VDA is for different because
MSME?
I'm not delivering on that training, so I can't speak about that.
Okay.
Sir,
Yes.
sir, actually I am a BTech dairy technologist. Is there any future courses or training sessions that may help my resume to boost?
Yes, we can discuss it offline. You can just text me.
Okay, sir.
Normally, you can text me, and when I have time, I will call you back.
Okay, sir. Thank you.
Okay. So, once again, thank you, friends. And because
Thank you so much, sir.
normally, as yes, yes, Paramita, yes.
Sir, are you
Thank
also
you,
providing
Kiran.
Six Sigma training?
Yes, we are thinking about that Six Sigma. At least for Yellow Belt and Green Belt, we are starting. We are thinking to start.
Yes, sir. Thank you.
Sir, will start our MSME?
So good night and nice meeting all of you.
Sir, sir, actually, when I want to take the training about the Six Sigma, is it okay if I'm directly jumping to the green belt instead of
Yes, yes,
completion of yellow?
yes, 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 yes. You can go to the
Because
green belt.
yes, because of I will work
Yellow
for
is for basic because yellow is basic. And normally we use the QC story approach or DMAC, just introduction of DMAC and QC story approach. But you can
yes,
directly go for the green belt.
right, sir. Thank you, sir. Thank you very much, sir.
Hello.
Thank you, thank you.
Sir,
Yes,
actually, I want to ask something.
yes,
Sir,
yes,
I am
Gitanjali.
Gitanjali. Sir, actually, I want to
Hmm.
do a lead auditor certification. So, can I go instead of internal auditor to direct lead auditor
Yes, yes,
certification?
you can go to lead auditor.
So, sir, please suggest me which one is the better one, IMS is the or BRCGS?
Yes, you can text me. We will discuss. There
Yes,
are
sir, sure,
lots
sir.
of yeah.
Okay, sir. Thank you, sir.
Thank you, thank you,
Thank you, Mr. Kiran. Good session.
thank you, Venkatesh.
Okay, sir. Thank you. I will connect you, sir, soon, very soon. Again. Thank you, sir.
Definitely, yeah. Oh, yes.
Thank you, sir, for the class.
Good night.
Thank you, sir. Good night.
Yes, thank you once again. Thank you. I will stop recording.